Hello and welcome to video number 5 in this series. In this video I'll review how fraction addition and subtraction works. So let's start with a case where we are adding two fractions with the same denominator. So a over b plus c over b. So all we do is keep the denominator and then add the numerators. So, for example, we could have 3/5 plus 1/5. So we'll keep the denominator, the 5, and then add the numerators. So 3 plus 1 is 4. So the answer is 4/5. So why does that make sense? Well, if we think about a fraction strip, so if I divide it into fifths, so 1, 2, 3, 4, 5. Let's have another fraction strip. So 1, 2, 3, 4, 5. And then let's have 3/5 shaded in the first fraction strip. And then 1/5 shaded in the second fraction strip. Then if I add those pieces together in a third fraction strip, then in total I'll have the 3 pieces here and then the 1 piece here. So I'll have 4 in total. So that's if we have the same denominator. But what if we have different denominators? Oh, no. Back that up. I got to do subtraction first. So that's adding fractions with the same denominator. What about subtracting fractions with the same denominator? So for example, let's do 3/5 minus 1/5. Again, because we've got the same denominator, we can see that we can subtract 1/5 from 3/5 fairly easily. It's just a matter of subtracting the numerators. So we'll keep the same denominator again, the 5, and then 3 minus 1 is 2. So that's when we have the same denominator in both fractions. What if we have different denominators though? So for example, how could we add 3/5 and 1/3? So now we have different denominators. We've got fifths and we've got thirds. So now if I try and draw it the way I drew it over here with the fraction strips, we're going to have a fraction strip divided into fifths, and we'll have 3/5 shaded, and then we'll have a fraction strip divided into thirds, and 1/3 shaded. And over here we could add the pieces or we could subtract the pieces because they're all the same size. But now we can't do that because the pieces are different sizes, and so it's not possible to add them together or subtract them from each other. So we need a way to make the pieces in the fraction strips have the same size. So we talked in a previous video about creating equivalent fractions, and so the idea is going to be to create equivalent fractions for these two that have the same denominator. So to do that, in general, we're going to have now a over b and c over d. So how can we create equivalent fractions for these two that are going to have the same denominator? So one way to do that is if I take this first fraction, a over b, and I multiply it by the number 1, then its value won't change, but I can change the denominator depending on the fraction I multiply by. So let's multiply it by a fraction that's equal to 1 that consists of the denominator for the other fraction in the numerator and the denominator. So d over d. And then the other fraction, we can see that the new denominator for the first fraction is going to be b times d. So I need to get the denominator for the other fraction equal to b times d. So if I multiply this fraction by b over b, then I'll end up with the same denominator for both fractions. Okay, so I'm multiplying the first fraction by a fraction that's equivalent to 1, consisting of d divided by d, and d is the denominator of the second fraction. And then I'm multiplying the second fraction by a fraction equivalent to 1 that consists of b divided by b, where b is the denominator of the first fraction. A lot of words going on here for something that in practice is hopefully straightforward. So in total, I'll have a fraction that's got a common denominator of bd, and then I just apply this. I just add the numerators. So AD and BC. So let's see how this works in practice with our example up here. We'll have 3/5, and then we'll multiply by something, and then we've got 1/3, and we've got to multiply that by something too. So what are the things we have to multiply by? So the first fraction, we've got to look at the denominator of the second fraction, and put 3/3 here. And then the second fraction, we've got to look at the denominator of the first fraction, and put 5/5. And so now we'll have 5 times 3 in the denominator, so 15. And we'll have 3 times 3 and 5 times 1. So overall, we'll have 14/15. And so why does this work? I mean, we can kind of see how it works algebraically, but it's nice if we've got an intuitive sense of why this works too. So let's go back to our fraction strip picture. We've got 3/5 up here, and what we did was we multiplied by 3/3. So it's like we're taking these fifths and breaking them up into 3 pieces in each piece. So we've got 9 smaller rectangles there, 3 times 3. And then in the other fraction strip with the 1/3, we're multiplying that by 5/5. We're breaking up the thirds into 5 pieces each. So there's only one of the thirds is shaded, so I'll only break that piece up into 5 pieces. So now I've got 5 smaller pieces equal to 5 times 1. And now all these small rectangles up here are the same size. And so that's put me back into this situation here, and I can add the 9 small rectangles in the first fraction strip to the 5 in the second fraction strip and end up with 14 in total. So that's how fraction addition works when we have different denominators. Fraction subtraction, when we have different denominators, would be similar. We would just do subtraction in this step, but otherwise multiplying by the fractions equivalent to 1 would be the same. So let's work through a few more examples where we have different denominators. So let's start with 1/3 and 3/8. So I'll just write down the 2 fractions again, leaving a little bit of space. And I'm going to multiply each fraction by a fraction that's equivalent to 1 to make us have common denominators. So for the first fraction, I need to multiply by 8/8. And the second fraction, I'm going to multiply by 3/3. So we'll have 3 times 8 in the denominator, 24. And then we'll have 1 times 8, which is 8, and 3 times 3, which is 9. So we'll have 17 out of 24. And then let's do a subtraction example. Let's do 3/5 minus 2/7. So I'll write down my fractions again. I'll leave some space so I can fill in the fractions that are equivalent to 1. So the first fraction, I'm going to pick up the denominator from the other fraction. And the second fraction, I'll pick up the denominator from the first fraction. So I'm going to have 5 times 7, 35 in the denominator. And then I'll have 3 times 7, 21, minus 5 times 2, 10. I'll have 11/35. And then let's do one more example. Let's do 5/8. Let's do an addition 1/6. So 5/8 times 6/6. And then we'll have 8/8 times 1/6. So now we'll have 6 times 8, or 8 times 6 is 48. And 5 times 6 is 30. And 8 times 1 is 8. So I'll have 38/48. And that one's not in lowest terms, because there's a common factor there. There's a common factor of 2, I think. So we're going to have 19/24. In previous videos, we've talked about always look for shortcuts when you can, often involving pulling out common factors. And here, if I'd been paying a bit more attention, I could have seen here that to get a common denominator for 8 and 6, I don't need to go all the way to 48. I could use 24 instead. If I multiply 8 by 3, I'll get 24, and if I multiply 6 by 4, I'll get 24. So instead of doing what I did before, I could do 3/3 times the first fraction and 4/4 times the second fraction. And that way I get straight to the answer without having to do this last step, because I got 24 in the denominator, 8 times 3, or 4 times 6. And in the numerator I'll have 5 times 3, 15, and 4 times 1, 4. I'll have 19 over 24. So pause the video here and see if you can work the next two fraction, addition, and subtraction problems yourself. And again, try and resist using a calculator. Just use the methods we've shown and see what you can come up with for these two examples. So we'll do 1/4 plus 4/7, and for the second one, let's do 5/9 minus 1/3. So for the first one, we've got 1/4 plus 4/7. So if we do 1/4 times 7 over 7, and then 4/7 times 4 over 4, we'll have 28 in the denominator, and then we'll have 1 times 7 is 7, 4 times 4 is 16, and 7 and 16 is 23. For the second one, so we got 5/9, and we got 1/3, subtracting. So we want a common denominator here. I could multiply 9 by 3 and use a common denominator of 27, or I could use one of these shortcuts that we're always looking for, and notice that 9 is actually a common denominator here. So this first fraction I don't really need to do anything to, just multiply it by 1 over 1. The second one, multiply it by 3 over 3, and so now we've got 9 as the common denominator, and in the numerator we're going to have 5 times 1 is 5, minus 3 times 1 is 3, so 5 minus 3 is 2. So that's all for this video. In the next video we're going to switch gears and we're going to start looking at numbers with exponents.